Okay, guys, so we only have 3 more to go. Let's go ahead and work on number 17. Okay, 17, 18, 19. That's 4 more to go, and we are going to get started. So let's look at B. The answer to this is B, and let's talk about how we got there. So in a college art class, 76 students are painting murals on one wall of the campus amphitheater. The wall has been divided into 23 sections, and each section will be painted by a group of either 2 or 4 students. How many more sections will be painted by groups of 4 than by groups of 2? All right, so we know we've got 76 students. So I know that if I have the groups, there's 23 sections, so technically there's going to be 23 groups. Does that make sense? So I know I'm going to have groups of 2 students and groups of 4 students. So let's let T be the number of groups of 2 students and F be the number of groups of 4 students. So T plus F has to equal 23 because that's the number of groups given the number of sections. Altogether, though, there are 76 students. And I know that for each group of 2, that's 2 times T will give me the number of students that are in groups of 2. And then 4 times F will give me the number of students that are in groups of 4. So then I get 76 as an answer because that's the number of total students painting this mural. At this point, I need to get rid of something so I can solve for a variable and do my thing. So let's go back to the question. How many more students will be painted, how many more sections will be painted by groups of 4 than by groups of 2? So I need to figure out what T is and F is in order to figure that out. Does that make sense? All right, so calculating T and F, we're going to do the same thing. We can do substitution, we can do elimination. Let's do elimination for good measure. So I'm going to multiply this top equation by -2. And what that's going to do is make sure that T, this will be a -2t and this will be a +2t. They will be additive inverses, and I'll be able to eliminate that. So I have -2t, I'm multiplying through, minus 2f is equal to a -46. I'm going to put my second original equation down here, and I'm going to do exactly like you think. I'm going to add them together. These guys cancel out. I'm left with 2f is equal to 76 minus 46 is going to give me 30. Therefore, there are 15 groups of 4. Does that make sense? 15 groups of 4. And if there's 15 groups of 4, and I know that there's T groups of 2 and F groups of 4, which is now 15, I'm going to subtract from that, and I get that T has to be equal to 8. Making sense? So 8 plus 15 is 23. That lets me back solve. Let's now go back to the question. So T is the number of sections being painted by groups of 2, and F is the number of sections being painted by groups of groups of 4. So how many more sections will be painted by groups of 4 than by groups of 2? So I'm going to subtract the 2. 15 minus 8 is equal to 7. Does that make sense? I hope so. I know it got a little bit confusing. Are we talking about sections or are we talking about groups? In the way groups and sections kind of refer to the same thing. All right, let's go ahead and take a look at the next one. So here for number 18, your answer is D. It's going to be 33 over 8. And I understand. I'm looking at this and I'm like, oh my gosh, fractions, don't really want to deal with them. So what we're going to do, just wanted to make that bigger because I was feeling like that was pretty tiny. We're asked, it says, in the ordered pair x, y, if some point x, y satisfies both of them, what is the sum of x and y? So clearly we have to find x and we have to find y, and we've got to actually figure it out. There's no way to kind of make this into some x, y and do something fancy or slick. So let's go old school. Let's do what we have to do, which is simply to figure out if we're going to substitute or eliminate. But wait, the fraction is still a bother. So I love the fact that algebra gives us power to manipulate equations so that we can get them to be what we want them to be. And in this case, I would really like not to have fractions. So what I'm going to do is I'm going to multiply the top equation on both sides by 8, because 8 is the common denominator of the denominators here, and that's going to make good things nice for me. And I'm going to do the same thing with the bottom by choosing a common denominator, but this one's going to be 6. And I'm going to multiply each term inside of the parentheses by 8 at the top, and at the bottom I'm going to multiply by 6, and what I get is the following two equations down here. So these equations basically I multiply through by 8 all the way across the top, and this is what I get. And when I multiply through by 6, this is what I get. You can check my work and see if it doesn't work out. So now we got to solve for x and y, and we're going to do the same thing, same choice. Do we graph it? No, graphing's horrible. Unless we have a graphing calculator or something, whatever. So do we graph it? Probably not. Do we use elimination or substitution? Either one is fine. Let's do elimination. I'm going to multiply this entire lower equation by -5, because this way I'm going to get rid of my -5. When I do that, I get the following two equations right here. I rewrote the first one and multiplied by -5 and did my thing. So now I do this, these cancel, which is what I wanted. I'm left with 48y is equal to 12 plus a -30 is going to be like a -18, I believe. And then so I get that dividing both sides by 48. I get that y is equal to, and I can reduce this recognizing that 6 goes into the numerator and denominator, -3/8. So that's my y value. Okay, I am so glad that there's an edit function on this thing, because I just went through a whole mess and did bad things. So I'm going to do the right thing for you. So now that we've got y, let's figure out what x is. Instead of using one of the fractional equations, which we could use, let's use one of the modified ones that's kind of a little bit easier to deal with. So if I do 5 times x, which is what I'm looking for, plus 28 times y, which is -3/8, is equal to 12. Now all I need to do is solve for x. So what I'll do is I'll say, okay, well 5x is equal to, all of this stuff is going to go over to the other side, so I'm going to put it there because it would be like 28 plus times a -3/8 is going to be a negative whatever that is. So when I bring it to the other side, it's going to be positive, right? So I'm going to just do that plus 12. I hope that doesn't feel too tricky to you. When I multiply two fractions, I can, do the straight out multiplication, but I can also cross cancel, which says, okay, if these guys have a common factor, which both of them can be divided by 4, when I divide 4 into that one, I get 7, and when I divide 4 into this one, I get 2. I therefore can rewrite this as 5x is equal to 7 times 3, 21/2 plus 12. It's never convenient to deal with a whole number and a fraction, so I'm going to make this into a fraction as well. 12 can be written as 24/2, right? If I wanted to have a common denominator. So let's do that. I'm going to write it in red so when you look over it, you'll know that something happened. All right, so now that we have that, I'm going to add these guys together. I get 45/2. When I'm adding fractions and the denominator is the same, just add the numerator and the denominator comes along for the ride. Now I need to get x by herself. That means I'm going to multiply both sides by the reciprocal, or in a sense, I'm going to divide by 5, right? And so therefore, x is equal to, I know this is a lot of work, 5 goes into that 9 times, and this is going to be 9/2. Not 9/9, people, 9/2. So the fact that I have this x value that works out well, I'm done, right? Not quite. I gotta do the product, right? No, what is the sum of x and y? So now I've got to take 9/2, torture, plus -3/8, and I've got to see what I get. Well, I need a common denominator when I'm adding fractions. Clearly that's going to be 8. So this becomes 72/8. I just made that up. That's a lie. The common denominator is 8, but I need to multiply top and bottom by 4 in order to get 8, so I should have had 36. Sorry, bad math teacher. So 36/8 plus -3/8 is going to give me 33/8. Whew. Hopefully, even though that took a while, hopefully you understood the steps. If not, let's talk about it, because this is definitely up your alley, even though it is in the latter part of the practice section, which we know it's a harder problem. Let's take a look at this next guy. So looking at number 19. Number 19, we are given these two equations, and it says in this system of equations, in this system, above, k is a constant, so it's just a number. If the system has no solution, what is the value of k? Let's go back. We remember systems have no solutions when the lines are parallel. We know that lines are parallel when the slopes are the same, but the y-intercepts aren't. If the slope and the y-intercept were both the same, then we'd be talking about the same line, which is not parallel or not no solution, that would be infinitely many solutions. So in order to have no solutions, I need the same slope, but I need them to be parallel but not have the same y-intercept. Just something to think about. So now that I'm recognizing that, I know that I need the same slope. I know that K is going to give me the slope. Well, how do I find the slope? Well, what's the slope of this guy? To find the slope, I'm going to solve for y. And so I have negative 24y. I'm throwing the 11x over to the other side, so it's a negative 11x plus 8. Divide everything by negative 24. I get y is equal to negative 11 over a negative 24, which is positive 11/24. Stay with me. X plus 8 over negative 24, which is irrelevant. I just need to make sure that my y-intercepts are different. So over here, I need to go ahead and try to solve for y in the same way. Throw the kx over to the other side. I have negative 36y is equal to negative kx plus 5. Divide everything by negative 36. And when I do that, I get that I'm going to get 5 over negative 36, which is cool because I want them to be different. Now I'm going to just focus on making sure that my slopes are the same. So 11 over 24 must equal K, negative K, I believe, negative K over a negative 36, right? Well, since they're both negative, that kind of renders the negatives irrelevant because a negative over negative is a positive. So 11 over 24 must equal K over 36. This is just a proportion. I can cross multiply and solve. And so you can use a calculator, so this isn't too bad. I get 24K is equal to 36 times 11 is going to be 396. 396, I believe that's right. Yeah, I think that's right. And then I'm going to divide both sides by 24, and I get 32 over 2, or 16.5. All right, so we have this last problem. We've got Mallory. She's got two types of plants, and they have different lengths, and they're going at different plant rates. So let's call them vines. So we've got vine 1 and vine 2. And we're told that vine 1, when she bought it, was 11 inches, and it grew at a rate of 0.25 inches per day. And the other, so that's going to be the length equation. So the length equation for vine 2 is a little bit different. She bought it at 24 inches, and it grows at a rate of 1.25 inches per day. And I'm actually going to change this variable and not use inches, but use days. So for each day it grows, I get to add on either 0.25 or 0.125, depending on which vine I'm referring to. Now, the tricky thing here is that we're talking about 20 days later she purchased this one. So after 20 days later, this vine, this original vine, has to have grown from the original 11. In fact, we knew it grows 0.25 inches per day. So if I take 20 multiplied by 0.25, I'm going to get an additional value of 5. So by the time the second vine was purchased, when I add 5 to the initial growth of 11, I'm going to get 16 plus, and it's still growing at a rate of 0.25 inches per day. So now the D's that I'm talking about here, in a sense, the D's that I was talking about here weren't the same. This D was less, was started off, we're talking about days before, but now this D here, and let me highlight them in maybe red, both of these are now the same. So now we can get started with our problem. Okay, so now I'm going to set these two equations equal to each other because we're talking about the same number of days, because we want the lengths to be the same. So when I do that, so this equation is going to help me find the number of days after the 20 days that it's going to take for them to be equivalent in height. I'm going to subtract 0.125D from both sides, and on this side I'm left with 0.125D. And if I subtract 16 from both sides, this side I'm left with 8. When I divide both sides by 0.125, I'm actually going to get 64. So D, oh, you can't see that. Let's see. Scroll down a little bit. That D is equal to 64. So that takes 64 days for them to reach the same height after the original 20 days. So then I have to add 20 back into the equation, and that's how I get my answer. So the answer is 84, and I think I erased it from what I had before, but the answer is going to be 84. And that's what we get. I hope that made sense. Please feel free to ask questions. Try the problems over again now that you have a better idea of how to approach them, and I look forward to talking to you guys soon. Take care.